Next up, we have Geoff Pool, who's going to be presenting from Minix to GNU Linux, a retrospective. Geoff was here late last night, fussing over a kernel compile on a 4 megahertz machine. I don't know what else to say. So thank you. Geoff, thank you. Here you go.
Thank you, Mike. Thank you to the Federation for sponsoring the event and also for the Living Computer Museum for hosting us today. Thank you all so much. All right. So, the first question I have is, show of hands, who here owns an Android cellular phone? Raise your hand. Shame on all of you. You did not add to the bottom line of the most capitalized company in the history of man, Apple Computer. Shame, shame, shame. That being said, all of you are happy owners of the Linux operating system. You use it on your phones. We use it in supercomputers and everything from big to small in between. There's a story about how all of that came to be, and this is what today's retrospective is all about. We're going to retrace those steps. I hope you'll find it entertaining, and please hold your questions towards the end because we will have time to talk about them. So, to begin, I just would like to also acknowledge some people who are here and who are not here anymore that helped bring us to this point. You may not know J.C.R. Licklider, aka Lick. He was an MIT psychologist who wrote a famous memo, The Intergalactic Computer Network, visualizing the idea that we could all be connected electronically, instantaneously, and it would be for everybody. And now, of course, we have that in the internet. And of course, we can't forget Ken and Dennis. Ken Thompson is Dennis Ritchie. Dennis is no longer with us. And the rest of Bell Labs, because Ken wanted to play a game on a PDP-7 computer. And, well, he found one. And then they decided to make an operating system. And it grew legs. And it left Bell Labs. And it was litigated. And now we run a Unix-like system called Linux because they had a vision. And we'll talk about that. Dr. Richard Stallman, RMS. Anybody here know who RMS is? Let's raise our hands. So RMS and I were talking back and forth by email in preparation for this because I had questions and I'm a good fact checker. I did go to college. I did work in investment banking. I have a Master of Science in Finance. And I left because I was too moral. But I do like to get my facts checked. And he provided some interesting background, but he also gave us the GNU public license. The GPL2, which allowed, in part, Linux to spread like wildfire. I think we need to acknowledge that and remember that. Dr. Andrew Tanenbaum, we're going to talk about him too. He wanted to teach something besides theory, and he wrote an operating system called Minix. That gave us Minix, Linux kernel. And then, of course, finally, Linus Torvalds, good Finnish student of Swedish descent, created something magical just for all of us, just for fun. And, of course, Unix is a trademark of the Open Group, and Linux is a trademark of Linus. Just in case there's any lawyers out there, I've said it and we're done. So today we're going to talk about the past's prologue, or things that happen to help us finish the kernel, and I kind of alluded to some of that in our opening comments. Unix, the operating system, new project. Minix as a teaching tool and an inspiration. The early days of the Linux kernel, the growing years, and we're going to stop at 1994 when the first 1.0 version of Linux came out into the wild. And then looking back and lessons learned and everything else that I can think of. So, in 1969, who remembers 1969? Am I the only one in this room? Oh, God. I feel so old. Anyway, 1969, the ARPANET transmitted the words low. And low, by the way, in Latin does mean low. Means behold. It means look. It's like, wow, we've got something here. And it is the ARPANET, the idea that we could have a terminal that could talk to another terminal of any type, class, or color without any type of discrimination, orientation, economic status. All terminals are created equal. Doesn't matter if you're a green terminal or an amber terminal. You can talk to each other and there is happiness in the world. And that ultimately allowed for us to have a TCP/IP packet switching network we now call the Internet. And there's an amazing story about that. And if you're curious, you have some books to read if you haven't. But also in December 1969, Linus Benedict Torvalds was born in Helsinki, Finland, the son of a revolutionary socialist. Those people. Anyway. So in 1969, there was this idea floated around. And it was floated around to create the ultimate time-sharing system. Everybody who was involved was enthusiastic, decided that we could make it work, got together. Now, the players in this get-together were not a bunch of corporations. They were the worst of all actors. The government and the academic institution. Imagine trying to plan out a project where every meeting starts with signing up for classes and then going to the DMV. Not fun. But GE stuck into it. Bell Labs said, we're done with this, and left. But Ken wanted to play his game on a PDP-7. Found one. And he played his game and he started to think about an operating system that had all the good features, not the bad features of Multics. And it was a pleasant environment in which to write and use programs, according to Ken. It was written in assembly language. They called it Unix, play on Multics, which means Unix information and computing service instead of multi-user information and computing service, which was Multics. And of course, they decided that CMS maybe would be better as an X, and now we call it Unix. It was ported to the PDP 1120 in 1971, and it was used internally at Bell Labs. Bell Labs was a government-sponsored monopoly back then. That means that they were a monopoly. They were sanctioned by the government to be a monopoly. They had a big research department, and the research department could make anything it wanted to, but still had to find funding. So Ken and Dennis were trying to figure out, where are we going to find money? Who has money in a company besides the accountants who don't want to share it? The legal department. The ones who patented software and patented hardware. They wanted a document preparation system. And so Ken and Dennis said to them, well, we've got this thing called Unix. It's fun. We can support multiple users on it. Oh, and by the way, it allows you to change a page from a 400-page document and take out that period where it's misspelled. And you don't have to reprint the whole thing. And the legal department was very happy about this option. And that is what internally led to the continued and further development of Unix. Those lawyers. It's a very simple design, and it's clever uses of shells, pipes, and I/O redirection, fancy words. But it just simply means that we got a place to put information in, we can move information around simply, and we can get it back and forth from memory and disk quick. It's nice, simple, easy, and it works. And we don't see stop codes with the word blue screen. So, 1973, Bell Labs said, well, we'd like to try and see if we can make it portable, so we could put it on something else besides a PDP in our office. So they rewrote it in C language, which is a high-level language that was used to develop parts of Minix, parts of Unix. And it was also used to write things that they were using application-wise for the lawyers. And there were lots of people who said that no operating system should ever be written in a high-level language, that only true operating systems made by bureaucrats wearing blue suits visiting customers, they're always going to write it in assembly language. AT&T said, well, that's all well for IBM and their blue suits, but that's not our key. So they tried it, and they got it to work. And by 1974, when Unix version 5 was available to universities, they could take this code and they could move it around to architectures, including that Interdata behind us. The first computer that had Unix installed on it that was not in Bell Labs, running on a PDP-11. You can see it as you leave. It's kind of in the corner there, sitting by itself. It's lonely. Anyway. Universities were very happy to pay the license fee on this opportunity because the government-sanctioned monopoly couldn't sell the software, but if I license it to you for your usage, we can get money from you. We like money, said the lawyers. Money is nice. And at $20,000 each, there were a lot of universities who said, you know what, this is kind of exciting. You mean I can buy your software and look at the source code instead of having my IBM rep come in and try to explain to me why the 360 is a great option and I should spend more money and give them more money for a binary copy that I can't even figure out how it works except to push the button? No, it doesn't. Okay. And by 1976, Unix version 6 was also made available to both the universities and to corporations. So corporations could work at it. Corporations had a different view, but they weren't willing to spread around the joy. Universities, however, were lovely places to spread joy. And Dr. John Lyons at the University of New South Wales developed notes for teaching Unix version 6 because he wanted students to actually know something instead of being able to pass a test. And by passing the test, he didn't want them to just know that the question number 4, the answer is number 6. He wanted to know, he wanted them to understand that when you move registers around, when you put numbers into the system, that there's a reason why it should be there. Even though his notes famously say the parts, you are not expected to know this. But people tried it anyway. Moving along. This note, these sets of notes, 2 of them, for 2 classes, would eventually be condensed and compiled into a famous book called Lyons' Commentary on Unix, 6th edition with source code. It was very popular. Everybody wanted to get a copy of it. They could not at the university keep up with this. So by 1978, if you wanted to buy the Lyons book for your class in operating systems and to learn how to use your school's version of Unix 6, you had to go to Bell Labs. Bell Labs, of course, would be very happy to send a copy of the book and not a photocopied book that had been run through a couple of dozen times in the smudges and drops of pizza sauce and other things that students will drop on their books. However, all good things come to an end, and in 1979, Unix 7, version 7, was made available to the license holders, but there was a small little change, and that was you could no longer use AT&T's code anymore. Each operating systems, and you cannot show the source code anymore. That was received poorly. Very unhappy. And of course, that meant that the Lions book was no longer available to be bought. That was also meant poorly. So, universities said, well, I guess we're just going to have to go back and teach on the 360 or 370 or some other fancy device when a salesman wants to sell me. You know the salesman types. I'm about my height, losing some hair. Anyway, one professor, however, did decide he was going to change the world and took a different path, the path less traveled. So, we're going to return to that story, but there was another story going on, and that is that Dr. Richard Stallman, RMS, having been the systems designer and programmer for the AI labs at MIT, found that the AI labs were going away. All of the various Lisp programmers were going to go and make lots of money selling Lisp machines to from one of two different companies. And he was left all by himself and maybe another person or two, and the AI labs were going to go away. And he was not happy about this because he really enjoyed the AI labs culture of sharing software. The idea that my software is for everybody. And so he said, I'm going to create the GNU project. And that GNU project is going to be founded on the idea that software is something that is available to everyone, free. That software should be free, and not free as in beer that I'm going to give it to you and we're going to drink it, for smoke, I suppose. But we're going to share it. It's freedom as in libre, and condensed down into the four ideas that there are four qualities, basic freedoms, that you can use the software in any manner you choose. You can put it on your floppy, you can put it on your tape drive, you can have it with a mouse or in the house, or outside or inside or upside or downside. Anyway, you can modify that software. I really don't like how that prompt looks. And in fact, not only do I not like the prompt, I don't like the shell either. I'm going to make my own. But I'm going to take the existing shell and use that as my inspiration to make my own shell. And I'm going to call it Geoff shell or G shell instead of B shell or Bourne shell. And once I've modified it, then I can give that shell away to anybody who wants it. My neighbor next door likes my shell and wants to use it. They take that shell and they share it with their friends, and then they share it. And we distribute modified copies of that software, and it just goes on and on and on and on and on. And the court of public opinion rules everywhere. Peace, harmony, and joy in the world. That was what he wanted. The four basic freedoms. Remember those four basic freedoms, because we're going to come back to that for just in a little bit here. Now, so Professor Andrew S. Tanenbaum, he is of Dutch descent, got his PhD from the University of California in Berkeley. What a place to get it from, right? Anybody here ever been to Berkeley? Raise your hands. Berkeley is an awesome place. It's sunshiny, it's got a big college campus, it's got Telegraph Avenue, LBL. Now, of course, it has more people there because they want to live there, and it's lost some of its charm, but in the early 1980s, it's a pretty nice place. But he went to Vrije University, or Vrije, E-R-I-J-E, University in Amsterdam, the Netherlands. And he was going to write a program to replace Unix version 6 because he wanted something for people to use for teaching. That was his idea. Not only for teaching, but for teaching his theory of operating systems. And he published a book about it called Operating Systems Design and Implementation. And there's a copy downstairs if you want to go and see it. Minix was designed to be simple, easy to read, small enough in size to be understood by one person, and most importantly, because he had already seen the AT&T code, it had no AT&T code in it. 0. It was version 1, 12,649 lines of code, which is quite a bit, but over 3,000 of those lines did include comments. So the actual code's about 9,000. That's not that much if you think about a book. And for coders and people like that, probably the introductory paragraph of Windows 10 is 12,000 lines of code. Anyway, it was also compatible with Unix version 7 because that was the last version of Unix that was made available to universities, at least as far as licensee. Anything after that had to be paid for because AT&T no longer became a government-sanctioned monopoly. Thank you, Judge Green. Thank you for the Bell breakup. And it was also targeted to run on an IBM PC. Everybody knows what a 5150 is. Raise your hand. Heard of the 5150? Excellent. 5150, right there. That machine went on the market for $5,000. In 1981, it was sold to businesses by those guys in the blue suits, man. And they sold a lot of them. It was a monochrome monitor by default. If you wanted CGA, you paid extra. And it was built from off-the-shelf components. And we won't go down the rabbit hole of the BIOS and the DOS versus CPM. You could read all about that. But suffice to say, it was very successful. Not only was it was successful in penetrating a business market and left its footprint there that even today we are still largely using. We're just using its descendants with all of the foibles and fast processors and all that stuff. But it was originally designed, Minix 1 was designed to run on that machine with one 360K floppy disk. Who here has seen the downstairs demonstration of our floppy disk from our contributors? Anybody? Go downstairs and see that presentation so you can see what life was like before solid state hard drives. It's fun. One disk, one operating system, you turn it on and you're done. What a world we could live in. Now we have Windows. Anyway, so Professor Tanenbaum, his book, again we talked about operating systems design and implementation. With the two together, Minix and the book, you had a book to tell you how to do what you need to do, and software to run on an 8088 machine, which you probably got from your parents or the used computer sales store down the street, as my roommate did in 1987 for $1,000 with a monocle monitor and 2 floppy disks. And yes, you could code on it. You could write code and compile it. You could run your Unix shell. You could create scripts. You could create your own home directory. It could be yours, and it is awesome. And it all runs in front of you, and you can become a Unix hacker. But the theory goes. And there's quite a crowd on Usenet. Who here knows what Usenet is? All right. I love Usenet. I read the old Usenet archives quite a bit during my research period. And I went back to the very first posting on Comp OS Minix. And I also went forward all the way through, I think I stopped reading it at about 1993 or 1995 rather, because it got a little bit biased. But I was interested in what happened before. And there's a lot of interesting things that happened in Minix. Seeing it develop all the way to version 1.5, which came out in January of 1991. So Minix as an operating system was complete, but it did have a couple of small, minor things. First of all, it had a segmentation issue. What that means is this. When IBM built the 5150 IBM PC, they selected Intel to be the provider of the microprocessor, Intel 8088. It is a 16-bit processor with an 8-bit data bus, and it has a 20-bit address line, which means that you can only talk to 1,024 kilobytes of memory. And remember, as somebody famously said, 640K ought to be enough for everybody. Whether that remained true or not is debatable. However, all of that memory could only be accessed in segments or chunks, which were 64K in size. So when you wrote a program, you could not just write this program forever. You had to keep it under a certain size. And the maximum that the code could write for the compiler was 64 kilobytes of code, and then an adjacent 64 kilobytes, which would hold all of your data about your code. Variable name. If you find that variable, do this. And then also the stack, which is the temporary storage of what is being manipulated. And if the stack ever found the data, it would go bang, and there would be a famous message called stack overflow. Very frustrating if you're trying to fit programs to work in a small space, especially after you've been up for 3 days drinking cola so you can get your homework assignment done in time. Also, the 8088 does not provide what's called memory protection. And what that means is that my 64K segment might jump the rail, go over to somebody else's 64K segment, like the one being used by the operating system. And then it would really crash, and it would go halt. Big bold letters of 240 characters wide across the screen. So you, the programmer, had to know what you were doing if you were making code. And then, of course, lastly, we talked about a megabyte of memory. Who here remembers how much memory was required to run Windows 95? Raise your hand. Who here knows how much memory is required to run Windows 10? Raise your hand. How much memory is required to run Windows 10?
They recommend at least 2 gigabytes.
So, the gentleman here, thank you, sir. 2 gigabytes of memory is required for the minimum to run Windows 10. 1 megabyte into gigabytes is a big number. That's how far we've come. Minix also used a different system as an operating system called a microkernel. And I tried to think of the best way to explain this. My wife made some suggestions for me. She's a good New Englander, very practical woman. Basically, a microkernel is a really tiny little kernel, and all it does is it talks on both sides of its head. And it talks to both sides of its head because it's talking to requests that are coming in and out of the system, asking for things to happen. Like somebody just pressed a character. What am I supposed to do with that? Or I need you to ask the user what the first letter of their name is. All of that is being passed back and forth. It's very efficient. It's small. It's tiny. Because you've got one guy there. He's working 2 sides of the drive-through, and all he's doing is bouncing back and forth. Simple, easy, elegant. But it's slow because he's got to run from one side of the restaurant to the other, and he's got to go check in with the cashier to make sure the money cleared at times. It will slow things down, but it is very, very small, and it's easily understood. Dr. Tanenbaum feels that this is the best way to build an operating system, because that's his view. He has a PhD, and there's good reasons for him to say that. And that's why he made Minix, because he wanted to introduce his concept, his idea that this was a better way of building a operating system. Because the other operating systems in the world, like Windows, use what's called a monolithic approach, where we cram everything into the system.
Technically, Windows uses a like kernel where they have a sort of like kernel design, except some of the servers like published.
And I am being reminded that Windows 10 requires a hybrid kernel. I go back to when I was in Intel, we were using Windows 4. Windows 4 did not use anymore. They used a rather large monolithic kernel. But Unix version 7 was a monolithic kernel. And so was a lot of other operating systems. And they're big, they're fast, they run great. And as long as the driver is written correctly, as long as the system is talking correctly, it doesn't crash. But if it crashes hard. And that was the point that Dr. Tanenbaum was trying to make. Now, Minix also, because it's on a 640 kilobyte system, doesn't have what's called virtual memory or page swapping. So in other words, you've only got 640 kilobytes of memory. You're in, you're out, and you're done. There's no way to use that memory, move it back and forth. Most modern operating systems are using a combination of their hard disk, memory, and everything else to cache data and to manage the system overhead by fooling programs to think that there may be more memory there that aren't really there. It's called virtual memory. Linux doesn't have that. And that's a limitation if you're a coder, somebody who wants to build operating systems, or build applications rather. Minix 1.5 also really didn't have any networking capability. It did have a client for an Amoeba distributed operating system, or Amoeba distributed operating system, but it really only supported one small networking card, and Amoeba, although it was a very interesting idea, never gained really any widespread support. The networking we use is very different. And finally, with Minix, you're only allowed 2 backup copies. That's it. You can't share it with your friends. Everybody has to buy their own copy. So what's the difference between me buying Minix or Unix? A lot of money, but it's still not free. We can't share it. Now, Minix had contributors all throughout the early Usenet. And a gentleman by the name of Bruce Evans, who was a regular contributor to the Minix Usenet community, com.os.minix, had created a series of patches to enhance some of the limitations of Minix, to address some of these shortcomings. He also wrote a C compiler, so you didn't have to use the compiler, the Amsterdam compiler kit that came with the original distribution. And he called it Bruce's compiler, or BCC. These patches then allowed Minix to take over and expand its range to fully use the Intel 386 chip functions. Now we have 32-bit registers. We can span multiple memory areas. And we also get to do something called porting. And that means we get to take the source code for the GNU compiler back And we can make it run on Minix to create programs usable in Minix. This is a big deal because the GNU compiler collection was intended for professional software development, not academic. So along the way, in May of 1990, Linus, who lives in Finland, completed his mandatory one-year military service in Lapland. How many people have been to Minnesota? Raise your hands. Good deal. My relatives, my family is from Lapland. I asked my grandfather when they came to this country, why did they go to Minnesota? His answer was because they thought it was warm. This is why I haven't gone to Lapland. Anyway, having completed his mandatory military service as a ballistics officer, second lieutenant, he got himself a white cat, called it Randy, and there's a famous BSD hacker by the name of Greg Leahy, some of you may have heard of, once remarked, and of course, and conventional wisdom says that every hacker should have a cat. And he prepared for his second year of college. And in his summer reading course, he bought and took operating systems design and implementation. Okay. Because he also knew he was going to be taking that C and Unix class on a 16-user version of Ultrix at the University of Helsinki, and he wanted to be ready and prepared for it. I think about what I've read in between college classes, because I went to college for a very long time, and operating systems design and implementation or similar type books would not have been on my reading list, but hey, that's okay. Anyway, so he bought himself a machine in January of 1991, having finished his first order. And he spends about $3,500 on it, which is $64,052 in 2018 for his 386 computer. It was a 386-33DX processor with 40 megabytes of RAM and a 40 megabyte hard disk. Puts it together, starts playing Prince of Persia because it's taking 30 days for him to get his Minix 1.5 from the publisher. Because he ordered it, he didn't want to pay the college price. Can't imagine why. And when he got it, he installed it. 17 floppy disks later, it works. And he talks to Bruce Evans, who he's acquainted with, and he gets all the patches for Minix 386 to be installed. And he finds that Minix does not have a terminal program, so he decides to write one. And he wrote one, and that's Minix 01, believe it or not. And it's a simple terminal. It has 2 sessions, and it allowed him to read from the keyboard in the modem, and then also read the modem and put it on the screen simultaneously. So you have a screen going one direction and a screen going both ways. It's multi-threaded. He thought that was pretty nice. It also allowed him to get onto the university from home and read his mail and all of that fun stuff, because nobody wants to walk outside in pitch black at noon. I'd be in Helsinki in February of 1991. And while he's developing Minix, because he really wants to write his own kernel, he wants to do his own thing because he's curious and he likes to make things, he's looking for POSIX information because he wants to make whatever he's going to make POSIX compliant. He has quite an interesting time finding that. He talks about it in his book Just for Fun. that he had to go hunting around and call companies. They wouldn't give it to him, and finally somebody actually acquired it for him and sent him most of it. He also wrote a disk driver, and he ported Bash using GCC. And he starts moving some various small programs in and says, hey, this is pretty cool. I'm starting to replace this system, so I'm going to call this Linux kernel 0.01. He's pretty happy about it. And now he comes out in August of 25th of 1991, and the words speak for themselves. He announces to the world, hey guys, I'm doing a free operating system, just a hobby. Won't be as big and professional like GNU. For 386, 486 AT clones. It has been brewing since April and starting to get ready. I'd like any feedback on things people like, dislike in Minix, as my OS resembles it somewhat. Same physical layout of the file system for practical reasons, among other things. I've got Bash 1.08 and GCC 1.40, and things seem to work. This implies that I'll get something practical within a few months, and I'd like to know what features most people would want. Any suggestions are welcome, but I won't promise I'll implement them. Linus, and yes, it's free of any Minix code. It's a multi-threaded file system. It is not portable because it uses 386 text switching, and probably never will support anything other than AT hard disks, as that is all we have. Famous last words. So in October of 1991, he gets all this feedback that's coming in, and people are excited, they're happy, this is amazing. And he releases 0.02, and then he releases 0.03 in November. And a couple days after the 0.03 kernel gets released, darkness covers the land. He accidentally wrote one of his files, and it crashed the Minix portion of this. So he was faced with a dilemma. Do I reinstall Minix from scratch? Again, all 17 floppy disks? How many hours would anybody like to think I spent in the last day putting 17 floppies into my system to rebuild the kernel? Anybody? I spent from 3 o'clock in the afternoon on the previous day with a 3-hour nap, 5-hour trip up here, and we didn't get out of here until 7 o'clock the last night, having finally got the kernel to start its rebuild. That's almost a day and a half. Nah. He says I'm just going to continue to use my Linux system because it works. It works pretty well. And I'm still not getting the home. Sorry. So it's around December. He's happy with it. People are happy with it. They love Linux so much that a guy from Germany writes to him and says, Linus, this is so amazing, but I've only got 2 megabytes of RAM and GCC wants more. Can you help? And Linus says, that's an interesting problem. And so on the 23rd of December, decides that he's going to write a page to disk driver so it can swap back and forth from memory. Now that's not exactly virtual memory, but it's on its way. He starts it on the 23rd of December, and he finished it on Christmas Day. And he sent it off to the guy. And he responded, and he received a response back that it worked great. And this was the very first feature that was ever filled in Linux to meet somebody else's design. Pretty amazing, huh? So it's January 1992, and the Linux kernel 0.012 was released, and it was the first version covered by the GNU GPL. There's a little story I'm going to put into this to put it into context. When Linus was writing his product, he couldn't decide on his what he wanted to call it and how he wanted it licensed. And somebody, classmate, a friend, I don't remember which from the book, took him to see a presentation by Richard M. Stallman talking about freedom, as in Libre, and 4 software freedoms. My software should be free. And he came back from that and said, this is what I want it to be. So he decided to make version 0.012 under the GPL. And I've read many comments after the fact. And he has never regretted doing it. He could have monetized it. There's nothing that says he couldn't have done it, but he didn't want to do that. Now, he did not go to the GPL3 for various reasons. He said that the GPL2 met his requirements at the time. He'll stay with that. I think I know lower frequencies. It's like this. It's the speakers. There we go. But because of the internet and the page to disk driver that he wrote, it started to really, really spread, because suddenly everybody else who had not so up to speed systems could actually use it. And many other people started to request changes, bug reports, patches, and Linux took off like wildfire. And in January 29th of 1992, there was a posting on the Minix list from Dr. Tanenbaum saying that Linux was obsolete. And Linus responded, and it went on for about 2 weeks. And it raised lots and lots of issues. So I've summarized them here. Remember at the beginning of my presentation I said that Minix was designed as a microkernel. Dr. Tanenbaum did and does still believe that microkernels are a better architectural choice. Linus says, no, that's not the case. Monolithic works. The x83's 3-to-6 architecture and 100% portability, that was a discussion too, but that has largely been self-evidently resolved. And the free and non-free license, for all intents and purposes, has been as well. But we're going to talk about those a little bit more. But those are the 3 issues that were raised. And if you do want to go and look it up on Usenet, go to Google. You can Google that information and enjoy the entire thread. It's quite interesting. If you're having trouble sleeping, of course. Anyway, so afterwards, the Linux kernel goes through a couple of different major revisions through 1992, and it stalls in at about 0.99.x, which is 0.99 plus whatever number of iterations you want to throw out after that, for there were many, on December 13th of 1992, and it was really more refining the system. And finally, on March 14th, 1994, version 1 of the Linux kernel was released to the world to great fanfare and happiness. From the beginning, it took about 2 years and 7 months to reach the final first version. And it was built and designed and overseen by Linus, but many people along the world wrote the documentation, they submitted bug reports, patches, authored FAQs, how-tos, made postings, helped other people learn to install it, and generally made quite a splash in the world. And this, by the way, does include a fully homegrown version of the TCP/IP networking system. How many people here know, briefly, when the TCP/IP networking stack first appeared? Raise your hand. I've got someone who knows. So TCP/IP is not introduced with Linux. It was introduced by BSD. There's a very long story about it. But suffice to say, by the TCP/IP stack, as we all love and know today, really finds its origins and final implementation in 4.2 BSD, which comes around at about 1983. And this opportunity to build it by hand in the university system is what gave it its stress test and tolerance, because they were like, sure, you can hook up this big code onto our network, we don't care. Not anymore, but now they do, or then they didn't. And just some factoids here. The first public version of the Linux code was about 10,239 lines of code, and it was now 176,250 when it reached the end in 1994. That's a bigger than 16 times size growth. And for comparison, 4.17 of the Linux kernel, which was in June 2018, had over 25 million lines of code. So what do we know? What did we learn from all of this? Well, we learned that it proved once again that large groups of people with common purpose can build and refine a critical piece of software that was not for the sole purpose of creating profit for themselves or a company. That's kind of important when you think about companies who want to sell you software. Who here has gone out and bought a piece of software in the last 12 months? Enough, right? That's hard money out of your pocket. It also proved that the GPL is not a hindrance to companies being able to sell software. And it made sure that free software is here to stay. And it also made sure that companies could add in or sell services for free software and make money for their companies in spite of it being free. So we're going back to the Tanenbaum debates. I'm going to just briefly go over the free software and portability issue and to say that free software is here to stay and a lot of people like it. It's not the evil that it was assumed to be before. The Linux kernel, of course, has proved to be very portable because it was rewritten after version 1, and it is still quite viable and will continue to be portable across new architectures as they come out. I'm going to stay away from microkernel versus monolithic. That's the endless debate. But I will add one addendum, and that is that with a microkernel approach, there was a report that I read about a month ago or 2 months ago that said that a microkernel has the potential of having better security because of its smaller size and design. Take from that what you will. Minix in 2019, there are still people who use Minix. It's still around and being developed. Its focus has changed from being a teaching application to a reliably fault-tolerant system, and it holds claim to potentially being the largest deployment of a UNIX-like system because Intel uses it as part of its Intel management system. Intel management, I as an IT professional can go in and access your computer, do anything possible, and you wouldn't even know about it. That's a pretty powerful piece of software with all kinds of security rules. Maybe. And it's also, by the way, Minix has now been licensed with a 3 licensed BSD code. It's commercial, you can do whatever you want with it, all the way back to 1. Just some references, and I'll make these available to those who are curious. The Dream Machine, Dennis Ritchie's Unix time-sharing system, the GNU Manifesto, the book Operating Systems Design and Implementation, which was now at version 3, a book from Glenn Moody, Rebel Code, where a lot of the source from this came, Linus's book Just for Fun, and for those who really are having trouble sleeping in the middle of the night, if you go to oldlinux.com, Professor Zhao Zhang has translated into English a very heavily commented listing of all the Minix 0.12 code, the first one, under the GPL. It's very thorough, it's very readable, and it's many, many, many hundreds of pages. I hope all of you will take the opportunity to take a month off. Read it. I did not. Okay, we have time for some questions. Please raise your hand and speak up because my ears are not as good anymore. I'm an old guy. Any questions? Someone asked a question. My bad jokes. Go ahead. So the question is, why does Linux have more popularity than the BSD system? I'll give you my answer. There are two reasons. Number one is that while Linux was being developed from 1991 to 1994, BSD was under legal lawsuit for most of that, not all, but most of that, because of licensing issues and because somebody decided to commercialize BSD. It was finally resolved in 1994. And while this is going on, because it's free of AT&T code, anything that was written for Linux could not be considered AT&T's property. That's been in the back. Thank you, sir. Please speak up.
Is SCO really dead?
Is SCO really dead? You know, I asked that question actually recently. And I'm going to give you the brief answer. SCO, the company, is absolutely dead. The bankruptcy trustee is not. And that is still going on in the footnotes of the dustbin of history. More to come. Next. Yes, sir.
What's SCO?
What is SCO? That's an excellent question. SCO, the Santa Cruz operation. Is that right? Yeah, thank you. Fact checking. They were the inheritors of the ability to sell System 5 Unix to any company and people who wanted to do so. They produced their own version of Linux, of Unix. And if you bought Unix from 1991 through about 1999, you were dealing with them or their successors. They decided that Linux couldn't have possibly been created without help of AT&T's proprietary code and sued them on this and lost their bid miserably after a very lengthy trial and appeal. And if you go to the website www.grok.net, I believe is what it is. You can read all about it, and if you're an aspiring lawyer who wants to know about intellectual property and trial, I recommend it. It takes 6 months. It will take you that long to read all the briefs. Next question. Yes, sir. Then I'm coming to the gentleman in the front.
So, at one point, Linux was using this versioning scheme where even was stable and odd was like new or testing, and now it seems to be different, and it seems like before it was different. So, like, when did this change and why?
I didn't hear the complete question. I'm sorry. You're going to have to repeat for my poor little ears.
Sorry.
That's okay.
Linux used to use a versioning scheme where even versions were stable and odd.
And then the odd even from 2.0 and 2.1, and then 2.2 and 2.3 and so forth.
When did that change and why?
That changed in 2.6. As to why it changed, Linus just decided that he didn't want to have a separate developmental version line, so he just had a separate developmental kernel instead. And did you have a question, sir?
Yeah, you were talking about the compilers that were created to do at this point. You said GCC installments, and then you mentioned Bruce. What was the one before that? Where did that go?
So the question was, what were the compilers used on Minix? So the original compiler used on Minix was called ACK, the Amsterdam Compiler Kit. It was licensed software. You could take a compiler course at Regis University or any other university for a lot of money and learn all about it and use that as your example. They included it with Minix because they needed, that's how they developed it. BCC then followed. It was made by Bruce Evans, and it was really for his 386 version of Minix. And Linus looked at it and said, well, okay, maybe, but GCC is coming out, and actually Bruce helped to get GCC ported, and that's what they've been using since. Yes, sir?
So because the management engine was deployed, at least starting in 2016, the Intel management engine was only deployed on Intel CPUs, and Minix version starting in 2016 with Skylake. Is this the biggest deployment of the Unix-like system, or is standard still just?
Okay, this regards the Intel management engine. Go ahead, and I didn't hear the rest.
So you were saying that it's the biggest deployment of Unix-like systems?
Yes.
Or believed to be?
It is believed that Minix is the largest deployment of Unix-like systems. And the reason why is because it's on every single microprocessor that's been created by the Intel Corporation since about 2005, I believe is when it started approximately. And they make a lot of chips. They really do. I used to work with them.
What I'm saying is that since they've only started using Minix in management since 2016,
So the Intel management engine has been in every microprocessor produced since 2005. It has been expanded in capability and size generationally based on different chips that have microprocessors that have been produced since then. So the original scope of it was limited in scope for what it would do. Today, it allows a remote user to fully access the system, especially with the UEFI BIOS, to make sure that the machine is essentially open for remote administration. It's designed for corporations. Intel pioneered, way back in the day, a product called LANDesk, which was one of the first remote access systems for a Windows NT 3.1 system. This was in 1996. They did it because their own IT department was spending lots and lots of money to send people out to every single user's desk when there was a problem. What a boon it was to be able to sit at your desk and say, hey, let me log into your computer and see what's bugging you. That way I don't have to spend money to have technicians running around and re-imaging your box with Windows 3.1 and MS-DOS 622. Any other questions? Oh, we'll give the gentleman the last one and I'll be quick. So we have to be quick.
What were the minimum requirements when Linux 1.0 came out?
So the question was, what are the minimum requirements for 1.0 of Minix? The same as for the original one. A 386 processor with at least 2 megabytes of RAM and also at least an IDE hard drive. That's it. All right. Thank you all for coming. If you want to know more or see Minix in action, please come downstairs. Thank you to the VCF and thank you.
It's thank you, Geoff. The good news is, as bad as a person as I am for cutting off the questions early, Geoff will be here for the rest of the day and all day tomorrow. Okay, so come visit him downstairs. He's in the labs area, and then be happy to show you his Minix system down there. On a program note, we have one more speaker this afternoon starting at 4. Chris has been patiently waiting on the side. He's got a great story about the Epson 2X10 and his early involvement with that machine. On other notes, Corey, help me out. Should I be saying anything?
Buy t-shirts?
Oh, yes. Geoff, please come over here a minute. You'll notice Geoff is wearing the official sanctioned t-shirt. You're not supposed to be in the building without one of our t-shirts on. So go downstairs, buy a t-shirt. If anything, you can stitch together a few mouse pads to make a t-shirt. Thank you, Geoff. That was wonderful. It's going to take a while to forget that. Thanks again. Come back at 4 o'clock. Oh, and a round of applause for Geoff, please. One more.